In this video, I will go over the homework that follows the lecture introducing how to differentiate power series term by term. And as always, I hope that you watched the lecture before attempting the homework. And now we are ready to go ahead and take a look at the homework. So the first question is to find the power series for the derivative of this function. And the first step is to express this function as a power series, and we're going to do that using the following identity, which only holds when the following inequality is satisfied. Now, with that in mind, our function can be written like this. And we can simplify it. And now that we have the power series for the function, we can find the power series. And by the way, all of this is only true when this inequality is satisfied. And now we can find the power series for the derivative of this function. Now, when we do that, we have to take the derivative, and we take the derivative term by term. So 6n comes down, and we have x to the power 6n minus 1. And now when we differentiate, we are going to bump the index up by 1 to avoid having a negative power. And now that we have done that, we have to rewrite it with n equals 0, and we're going to do that by, and it's a common step, and we're going to do that by actually, if we have to subtract 1 over here, it's called reindexing. We have to add 1 to every appearance of n. So if you want the new index to be 0, you're going to have to do this step. Now, I know, so here we have 6n plus 1 minus 1, so it's 6n plus 5. Now, I know that for some reason Newton doesn't do that, so if you enter this correct answer, it will mark it wrong. And that's definitely Newton's fault. Newton is making a mistake and forgetting to turn this 0 into 1. So this is wrong. However, to make Newton happy and move on, we're going to give this wrong answer. So pretty much when you take the derivative and you don't bump up the 0 index to 1, when n is equal to 0, you pretty much end up with a x raised to the power negative 1, which makes no sense. Yes, in this case, n is equal to 0, so technically it's gone, but a better way to keep it nice and clean is bumping up the index. Now, we're going to enter this as the answer. So we have this, this, and this. But keep in mind that this is wrong. At least in my opinion. All right. Another question. Same question. So step 1 is to take out 5, 6. Then use the identity. Simplify. And all of this is true only when the following inequality is satisfied. And now we're going to differentiate this term by term. And again, I'm going to do it the right way. Now I'm going to change the index. I'm going to reindex it. So we're going to have 15n plus 1, x to the power 3n plus 3 minus 1, so it's 3n plus 2, divided by 6n plus 2. So this is the correct answer, and I'm going to also make the wrong answer, just to make Newton happy. The wrong answer will be to keep that index 0. And you may ask, what exactly is the difference here? And if you really want to see the difference, let's just try to write a couple elements of each sum. So here, when n is 0, we have 15x squared over 6 squared. When n is 1, we have 15 times 2, which is 30x to the power 5 over 6 cubed, and so on. And what we have here is, let's take a look. When n is 0, we have x to the power -1 over 6. But luckily we have this 0 coefficient here, so it's gone. Plus, when n equals 1, we have 15x squared over 6 squared. And now you can see how it matches up, right? So the difference is in this first term. Having negative power of x makes no sense. It's not a power series. It has a different name, and we not study this phenomenon in this class. So Newton needs to fix it, but in the meantime I will be entering the wrong answer just so we can move on. Another one. We're going to take out -3 over -2. So we have 1 over 1 minus x to the power 9 over 2. This is equal to 3/2 sum of x to the 9 over 2 to the power n, and goes from 0 to , . And simplifying this, 3/2 sum of x to the 9 over 2 to the power n, and goes from 0 to infinity. And simplifying this, 3/2 sum of x to the 9 over 2 to the power n, and goes from 0 to infinity. And simplifying this, we got 3x to the power 9n over 2 to the power n plus 1, and this only holds when x to the 9 over 2 is less than 1. And to find the power series of the derivative, we're going to differentiate term by term. Again, I'm going to do the right thing. I'm going to bump up the index here. And we're going to re-index it. However, to make Newton happy, I'm going to write this the wrong way. And all of this is only true when this inequality is satisfied. Now we're going to find the power series for the derivative by differentiating this given power series term by term. So we have 7 times 7n, x to the power 7n minus 1, 9 to the power n plus 1, and I'll do the right thing. And then I'm going to change the index. So we have 49 n plus 1, x to the power 7, 8 plus 6 divided by 9 to the power n plus 2. But I'm gonna also write the wrong answer here. And this completes the homework. If you have any questions, please feel free to reach out.